Hi everyone. So we are going to talk about a concept in radiology that can be a little bit difficult to wrap your head around at first. It takes some really thinking it through and practicing it. We can't really practice it together because we are not in a classroom, but I'm going to give you homework to practice this that you'll bring the sheets back to lab. So that I can see that you guys have worked through this theory. Or not theory, this rule basically of localization techniques. And what this is it's a way to identify an object in a film, whether or not it is more on a buccal surface or more on a lingual surface. So let's talk about, before we jump into it too far, let's just state the objectives. So we want to know the reason for using a localization technique. We want to explain the principles of the buccal object rule. We want to identify clues to determine angulation change when given two similar radiographs. And we want to use principles of the buccal object rule to identify the location of foreign objects using radiographs. So here, object localization on the radiograph. So in your textbook, if anybody goes in and reads this chapter that's connected to the occlusal, it's occlusal and localization techniques, chapter 21, you may actually get more confused if you read the chapter in the book. So I would actually probably either encourage you to read it kind of with a grain of salt, or read up and look at it up until you get to the page 236, and then maybe just focus on the recorded lecture and the PowerPoints, because the textbook talks about the SLOB rule, or SLOB, and also the right angle technique. So there's other techniques that the result can be the same, but you apply different rules. And we're going to focus on the buccal object rule. It's the one that Amy liked best. It's the one that I've learned from her. Holly used it as well. So I just kind of want to stick to one rule, because otherwise I feel like it'll just be confusing. So the buccal object rule. So why do we need a localization rule? So what's the purpose of it? So when we are looking at radiographs are two-dimensional pictures of a three-dimensional object. So we're not flat, we're not pieces of paper, we're three-dimensional. But when we take a radiograph, everything gets superimposed on each other, and it's a two-dimensional. We see everything in just one plane. So things that are in front or behind each other end up getting superimposed on each other, and so then we can't tell if something is more out in the front or more buccal, or if it's more toward the lingual surface. So for example, if we look at this radiograph up here, we have this supernumerary, or this impacted canine. So here's the baby canine, and here's the permanent canine, but it's impacted. So the oral surgeon, or the not endodontist, oh my gosh, the orthodontist, when they go into retrieve this canine and put a bracket on it so they can pull it out, they don't know if the crown is facing more lingually or if it's facing more buccally, just by looking at this radiograph. If we look at this radiograph down here, we're looking at an impacted third molar. Well, if you just look at it, it kind of looks like the crown of the tooth is looking at you, so you might think, oh, it's buccal. This is the buccal surface, but we don't actually know that. We could be looking at the lingual surface, and the roots could be actually pointing lingually. So we don't know that. And then over here is another wisdom tooth that is superimposed over the mandibular canal. Well, we don't know if these roots are in the canal, if they're in front of the canal, if they're behind the canal. We don't know where these roots are in relation to the nerve. So the oral surgeon can't just go in there and rip out this tooth because they could cause nerve damage if in fact these roots were right in the nerve, right in the mandibular canal. So, and then again up here, we can see that this premolar is bifurcated. It has two roots. And so when an endodontist is doing a root canal, they can't just say, oh, this is just a one root premolar, when in fact it could have multiple canals, and you have to get all the canals, or else you're not going to get rid of the infection, and they'll just need to be, they'll still keep having problems, and they'll need a retreat. So they have to be able to identify if there's more than one canal, and then are they buccal, are they lingual, how are they in relation to each other? So these are all reasons, other reasons why we may end up using this localization is if you break off a needle, if you break off the tip of an instrument, figuring out filling materials, if it's buccal or lingual, if there's a salivary stone, where is this, again, that would be for a surgeon, where's the salivary stone located? Retained root tips and jaw fractures. There's all sorts of reasons to use this localization rule so that you can see where something actually is in the oral cavity in the mouth. So how does this work? So if we take two images, two similar views, but with different vertical or horizontal angulations, and we apply this rule that we'll talk about, it will help us determine when we change the angulation, we will notice that the object that we're looking at, whatever it may be, if it's bifurcated roots, if it's a supernumerary tooth, if it's an impacted molar, whatever the object is, when we take two films that were taken very similar but at different angles, we notice that the location moves of the object. Now, does it really move in real life? No, it doesn't. It stays absolutely where it was. But because our vertical angulation has changed and our horizontal angulation has changed, it's going to look like it's in a different place. So for example, this little supernumerary tooth in this image looks like it's right smack between the premolar and the molar. But then the horizontal angulation was changed, and also perhaps the vertical angulation was changed as well. And then all of a sudden this object moved from right in between the teeth to right in front of the premolar. So why did that happen? So we'll go on here to the next one. Okay, so here's the rule, and we have to break it down quite a bit because just reading it sounds confusing. But when two different radiographs are made of a pair of objects, the image of the buccal object will move relative to the image of the lingual object in the same direction as the X-ray beam is directed or aimed. So if we have two objects in a film, the object that is more buccal, or that is on the buccal side, will move in the same direction that you move your beam. So if you move your beam mesially, then the object that is on the buccal surface will also move mesially. If you look at within those two different radiographs that we're comparing here with this rule, if you were to then look at the lingual object is going to move distally if you have moved the beam mesially. So lingual objects move in the opposite direction of the beam, and buccal objects move in the same direction as the beam. And we really have to look at this to understand it more. So let's move on. Okay, so in this image, we're showing not changing the angulation, but just simply moving the BID either anterior or posterior. So this is demonstrating how we take our first image with the pink the pink color here with the pink arrows. That's our first image. We take this image And we see some kind of an object or something that we want to figure out where it is up here, as indicated by this red and yellow circle. So we take a picture and we go, oh, what's that? And where is that? I want to know where that is. So then the operator takes their BID, and they don't change the horizontal angulation. They just simply move the BID more posterior. So when they do that, the next film comes out, and well, look, nothing has happened. The little red object is still hovering over the distal root, but now we've cone cut, or we have a beam centering error, because they didn't change the sensor, and they didn't change anything with the angulation. They just simply moved the BID back. So they end up with a cone cut, and this object is still in the exact same place. So moving the tube head without changing the direction of the beam doesn't result in any information other than you've cone cut. So it's not about necessarily the movement of the tube head, it's the angle of the tube head. That changes everything. It's your angulation. So then we look at this next one. So this is demonstrating here. So we take our first picture with the pink, and here's our object hovering over the distal root with the pink. And now, instead of our angulation going straight through the contacts, we move our beam, or our BID, we move it mesially. So we turn the BID more in an anterior or a more mesial direction. And so what happens to our object? So our object goes from being over the distal root to being more over kind of the palatal root. But in general, we moved our beam mesial, and what happened to our object? Did it move mesial or distal? Oh, I kept calling this the distal root. That's the mesial root. Let me just see if it was that way over here. Oh, it was. Sorry. Okay, so what happened to our object? So we moved our beam mesial, and then our little object here moved in which direction? Did it move mesial or did it move distal? It moved distal. So that has to mean then, if the object is lingual, it moves in the opposite direction of the beam, and that's exactly what it did. So we moved our beam mesial, the red beam is more mesial than the pink, and then the object moved more distal. And you can kind of see these arrows are pointing mesial, but the object went more over the palatal root than over the mesial root. Okay, let's keep going here. So in moving the incisor film to the canine film to the premolar film, and the premolar film to the molar film, the beam is always directed a little bit more mesial in every time you move. When you're taking a full FMX, you're kind of slowly moving it in a slightly more mesial direction. When you take the incisors, you're just pointing straight posterior, and then as you come around, you're a little more mesial, a little more mesial, a little more mesial. There's not much change in the angulation from the premolars to the molars, although we do see actually sometimes I've talked to some of you guys in the room where we'll say, you know, our premolar film is a little bit angled, and then sometimes we kind of straighten out for the molar because our contacts are more kind of angled this way. Our key contacts is actually a little bit more angled, a little bit more posterior, and then you straighten out for the molars. So it depends on everybody's occlusion, and it's a little bit different. But in general, as you move back, if someone has a really nicely formed even arch, you're probably going to be changing your angulation a slightly more mesial with each picture as you head back toward the molars. Okay, so horizontal movement. So in the diagram, so that we're still kind of breaking down this and thinking about it in different ways. So this is still the same concept here. In the diagram on the left, the buccal, so this is our buccal surface. The yellow circle is the buccal, and the lingual is our red triangle. Objects of interest are superimposed over each other. So here we have this is our distal, there's a third molar, this is our first molar, and our buccal and lingual objects are superimposed over each other. Because the beam is directed perpendicular to both of them, and they are in the same relative position in a mesial and distal and vertical. So back and forth, front and back and up and down, they're pretty much in the same spot. But telling which one is in front of the other, which one is buccal and which one is lingual, you can't really tell unless you apply the rule. Both images are located above the second molar. So they're both hovering above the second molar. So in the diagram to the left, the beam is directed more mesial. So here we go. We've changed our horizontal angulation from going straight through the contacts to going more mesial. So we've changed our BID, so our central ray, our primary beam, is going more mesial than it was before. So notice what happened. The object that's on the buccal, it too headed more mesial, and the object that's on the lingual headed a little bit more distal. So on the radiograph, the buccal object of interest moves mesial, same direction as the beam in relation to the second molar, and the lingual object of interest, red, moves distal, opposite direction of the beam in relation to the second molar. So they didn't actually move, they're still in the mouth in the same place, but in the picture, the object that's more buccal moved mesial with the beam, the object that's lingual moved more distal when the beam went mesial. So then we can all of a sudden go, oh, I see the difference. This is my first film. They're in front of each other. This is my second one. And then because I know where I put my BID, now I know this is buccal and this is lingual. Okay, and then this would be just the rule in reverse. So here we've moved our BID more distal. So then we can see that our buccal object, we moved our BID, the central ray is pointing more distally. So now our object is now also going more distal, and our lingual object is going more mesial in the opposite direction of where we put our BID. Okay, I'm going to stop there and we'll pick up with some more actual images with the with x-rays. So go ahead and re-listen to this again if you need to before you start the next one, or just jump right into the next one.